The aim and objective of this experiment, it is to verify and to study and verify Ohm's law. The connection of this experiment, as stated in the schematic diagram of a practical verification of voltage division rule, it is stated here that from the DC power supply here, we have the positive and then the negative polarity. The positive polarity of power supply, it is directly connected to R1 and R2. Take note that the connection is series, that's why it looks like a circle. And then as far as the voltage connection is concerned, the voltmeter 1 and voltmeter 2 are the same, connected in parallel across R1 and across R2. So let us connect the wiring of this experiment, verification of voltage law. So we need to connect voltage or positive polarity of power supply. We will connect it to R1, which is 100 ohms. The output of R1, we will connect it to the input of R2, which is 330 ohms. And then the output of 320 or 330 ohms, which is the R2, we will connect it directly to the power supply. So take note that the connection, it looks like a circle because the connection, it is in series. So as far as the voltage connection is concerned, we will connect it in parallel. So therefore, since the power supply, it is a analog, the meter here, it is analog, we need to connect a digital meter. So we have the digital meter here. So positive with respect to positive, and the negative with respect to negative for monitoring purposes. This is for our monitoring purposes. And then across R1, we need to connect the voltmeter 1 across resistor 1. So this is the positive, and the other side, it is the negative polarity of our voltmeter 1. So here it is the voltmeter 1, and then with voltmeter 2, we will connect it also, the other one. This is the positive with respect to positive of voltmeter 2, and then the negative of resistor will be connected to negative also of the voltmeter 2. So take note that the voltmeter should be connected only in parallel as stated in the schematic diagram. So we will turn on the power supply. So since we check already the connection, which is 100% correct, so we will turn on the power supply. So in the first reading, we need to set the voltmeter into 10 volts. So after the 10 volt supply, so meaning we have a 10 volt supply here, considering that at 10.23 volts, this is the total voltage, take note that the resistor across the resistor, which is 100 ohms, we will measure the voltage across that resistor, which is 2.3, and then across 330 ohms, we have 7.84 volts. By inspection, if we will add B1, which is 2.3, plus B2, which is 7.84, the total, it is 10.21. Meaning, by inspection, our setup, our experiment for voltage division rule, it is correct. So, in this second setup of our experiment, if you will notice, it is now we are dealing with the current division rule. So, it is a practical verification of current rule. So the circuit, it is stated that from the power supply DC, we will use the 1 ammeter here, which is the total current connected to R1, R2, and then we have the R1 and the current 1 and then current 2. This is the total current. So we will follow what is stated in the schematic diagram. So as what is stated in the schematic diagram, we will perform it in actual connection. So this is the power supply. We have the power supply here. And then we have the voltmeter as a monitor for this power supply because this is analog meter and this is the digital meter. For accuracy purposes, to make it accurate, we need to use a digital voltage. This is the total current. This is the current one, and then this is the current two. So let us do the connection for the practical verification of current division rule. So it is stated that from positive power supply here, we will connect it to ammeter. This is our ammeter. Take note that in ammeter should be in milliampere and it is direct current because the power supply that we are using, it is direct current. So therefore, we will use also the ammeter range should be in DC range also. So as far as the ammeter is concerned, the connection should be in series with the ammeter. It means it is like this. From a DC milliampere here, the common, we will connect it to R1. Our R1, it is 100 ohms. And then our R2, we will get another side of negative, which is the common. We will connect it to another resistor here. Okay. Then the output of resistor 1, which is 100 ohms, we will connect it to ammeter 1. So it is the positive of ammeter 1, this one. This is the positive of ammeter 1, and then the positive also of ammeter 2. So it is the positive also of ammeter 2. So take note that this is the R2, which is 330 ohms. We will connect it to positive of our ammeter 2. And then, of course, stated in the schematic diagram also that we need to connect both common of the ammeter. So here we will connect both common of the ammeter here. And then from common, we will connect it to power supply. So from common, we will connect it to power supply. So as what is stated now in the schematic diagram, so it is like this. So by inspection again, so we need to connect from power supply, positive, we will connect it to the total ammeter for the total current, and then connected to two resistors, and then this is ammeter 1, and then this is ammeter 2. Then this is the total current which is given to this ammeter number 3. So we have the total current of ammeter 1 and ammeter 2. So let us consider also our monitor. So monitor for our power supply. So since this is analog, we will connect it in parallel with the digital multimeter. So that we will get the exact reading of our power supply. So let us on the power supply and fix it to 10 volts. So as you observe now, the voltage given by the power supply, it is 10, and then the total current the total current using the current division rule, the total current it is given by 128.1 ampere or milliampere. It is 121 milliampere. Take note that milliampere, the scientific value of this, it is times 10 to the negative 3. Then we have the across R1 or the current one, R1, we have the ammeter 1 reading of 97.7 milliampere. So then the current 2, ammeter 2, we have 29.7 milliampere. By inspection, if we will add 97.7 milliampere plus 29.7 milliampere, it is equal to 128.1 milliampere. So we can say that our experiment with respect to voltage division rule and the current division rule, it is 100% correct.